On the night of September 7th into the 8th, nearly 6.2 billion people, about 77% of the world's population, will have a chance to witness a total lunar eclipse, often called a blood moon. During this celestial event, the moon will glide through Earth's shadow, taking on a mesmerizing deep red hue that has fascinated skywatchers for centuries. Before we begin, make sure to subscribe to our channel for regular space updates. What makes this eclipse particularly special is its duration. The total phase will last around 1 hour and 22 minutes, longer than the eclipse on March 14th, earlier this year. A total lunar eclipse is one of the most breathtaking celestial events visible to the naked eye. Unlike a solar eclipse, which requires special glasses, anyone with a clear sky can witness a lunar eclipse without any protective gear. This event occurs when Earth moves directly between the Sun and the Moon, casting its shadow on the lunar surface. Lunar eclipses happen only during a full moon when the Sun, Earth, and Moon are in a straight line. But they don't happen every full moon because the Moon's orbit is slightly tilted relative to Earth's orbit. Unlike a solar eclipse, which can only be seen from a specific part of the world, a total lunar eclipse is visible from anywhere on Earth where the Moon is above the horizon at the time. That makes it much easier to witness. Millions of people can watch the same event from different time zones. A total lunar eclipse happens when the Moon passes completely into Earth's umbra, the darkest part of its shadow. During the penumbral phase, the Moon dims subtly. Then in the partial phase, it looks like a bite is being taken out of the lunar disk. So how does the Moon turn red? What exactly happens during totality? Let's explore the atmosphere's role. It all comes down to the way Earth's atmosphere bends and scatters sunlight. During totality, sunlight skims through Earth's atmosphere. Shorter blue wavelengths are scattered away, while longer red wavelengths are refracted into the shadow. The exact shade depends on dust, pollution, or volcanic ash. More particles make a darker red or brown. A clearer atmosphere yields orange or bright red. So depending on Earth's atmosphere at the time, the Moon can range from bright orange to deep brick red. Now imagine standing on the Moon during totality. What would you see? You would see a deep red Earth surrounded by a glowing ring of orange and red light, all the sunrises and sunsets happening at once around the planet's limb. The event unfolds over several hours as the Sun disappears and then reappears. When sunlight passes through Earth's atmosphere, Rayleigh scattering removes the blue light, while longer red and orange wavelengths are bent and funneled into Earth's umbra. It's the same reason sunsets look red. Shorter wavelengths scatter away, leaving reds to light the lunar surface. If the atmosphere contains lots of particles, say from volcanic ash or pollution, the Moon can appear much darker and deeper red or brown. If the atmosphere is clear, the Moon can be bright orange. If dusty, it will be dim and rusty. Since Earth blocks direct sunlight, the lunar surface cools dramatically during totality. Without an atmosphere to hold heat, temperatures can plunge to minus 100 degrees Fahrenheit or lower in the shadow. These rapid temperature swings can cause rocks to expand and contract, producing tiny cracks over time. It's a slow, cumulative process, something lunar geologists study using high-resolution imagery. Using binoculars or a small telescope enhances the view. You'll see subtle color gradations across the lunar disk. For photography, mount your camera on a tripod and use long exposures of several seconds to capture the red tones. This eclipse occurs just 2.7 days before perigee, when the Moon is closest to Earth, making it slightly larger than usual, though not a full supermoon. Expect a subtly larger apparent size and a deep, rich hue when totality peaks. Now let's look at when and where you can see it. All times listed are in Coordinated Universal Time. The penumbral eclipse begins at 15:28 UTC on September 7th. The partial eclipse will begin at 16:27 UTC, when the Moon starts moving into Earth's umbra. Totality begins at 17:30 UTC. The entire Moon will be engulfed in Earth's umbra. The total phase will last roughly 82 minutes until 1852 UTC. As the Moon emerges, the red fades and the bite appears on the opposite side. The partial eclipse ends at 1956 UTC. The penumbral phase concludes at 2055 UTC, bringing the event to a close. Viewers across India, China, Russia, Western Australia, East Africa, and Central Asia will see the whole eclipse. It isn't visible in North America. In the UK and Western Europe, you can catch part of totality as the Moon rises. According to calculations, about 6.2 billion people, 77% of the world's population, will see the total phase. A staggering 7 billion people, 88%, will have a chance to see at least some part of the eclipse. Keep an eye out for the bright object near the moon during the eclipse. That's Saturn, shining at its best. On the very next night, September 8th, Saturn will be even closer to the moon in a striking conjunction. Through a telescope, its rings will appear nearly edge-on. Tip: use binoculars, stabilize your camera on a tripod, and try exposures of several seconds for photos. This lunar eclipse will be followed by a partial solar eclipse on September 21st, visible from parts of Antarctica, Australia, and New Zealand. Also, the last 3 full moons of 2025 will all be supermoons, with the November 5th full moon the largest and brightest of the year. And before you go, check out our recent episode on the first images from the largest digital camera ever built at the heart of the Vera Rubin Observatory. Happy sky gazing! If you enjoyed this, subscribe for more space updates and hit the bell to get notified.